In this video, I'd like to talk about the ellipse. Here are the two standard equations of the ellipse. The only difference is the location of the a variable and the b variable. A is always greater than b, and wherever the larger value is in the denominator, whether it's under the x squared term or the y squared term, determines whether it's going to be an ellipse that's wider on the horizontal axis or wider on the vertical axis. And just to show you on their little diagrams here, the a value versus the b value. And now just to recall the equation of a circle, which is x minus h squared plus y minus k squared, which is equal to r squared. If we divide both sides by r squared, we end up with x minus h squared over r squared plus y minus k squared over r squared is equal to 1. So this is essentially the same as the equation for the ellipse. The only difference here is that your denominators, which are r squared, are the exact same. And now I want to look at a formula that comes in handy when working with the ellipse. If we have two foci, the distance from the center to one focus is the value of c. For this example, the distance from the center to the top, the shorter axis, is b. Connecting those 2 points together is the hypotenuse, which is a. And we can use the formula a squared is equal to b squared plus c squared. So this is essentially the Pythagorean theorem, but it's not written in the standard form that you may be used to. Normally, the Pythagorean theorem would be written as a squared plus b squared is equal to c squared. So it is essentially the same formula, but you want to keep in mind and just make a note the location of the letters are different when we're working with the ellipse. Okay, I had already mentioned that c is the distance from the center to the focus. B is the distance from the center to the ellipse, and this is along the minor axis, which is the shorter axis. And A is always the distance from the center to the ellipse along the major axis, or the longer axis. And I haven't indicated that value of A here, but in addition to being that hypotenuse, it's also this distance here. And now let's look at an example. Here we want to determine the standard equation of an ellipse with center at 2, 5, focus at 8, 5, and that passes through the point 2, 10. The first thing I'll do is just draw a grid so I can plot my points. So we have the point 2, 5, which is the center, a focus at 8, 5, and it passes through the point 2, 10. Since I notice that the focus is to the right of the center, this tells me that the ellipse is going to be a horizontal ellipse. And that's because the focus is always on the major axis. So if I write the equation of the ellipse, I know the a squared value must go under the x squared value. Also, it's worth noting that since the distance from the center to the focus is 6, that tells me my value for c is equal to 6. I can start to fill in more of my equation if I use the fact that the center is at 2, 5. So that gives me x minus 2 squared plus y minus 5 squared, with the y squared term being over b squared and the x squared term being over a squared. The whole thing is equal to 1. And finally, I can plug in my point 2, 10 into my equation for x and y and use that to solve for either a or b. So first let me rewrite my equation for the ellipse, and then let me erase the x value, erase the y value, and instead plug in x is equal to 2, y is equal to 10. So that leaves me with 0 squared over a squared plus 5 squared over b squared is equal to 1. So the first term becomes 0. I have 25 over b squared is equal to 1. So this means that b squared is equal to 25, which means that b is equal to plus or minus 5. Our b value must be positive, so that tells me that b is equal to 5. So now I know that c is equal to 6, b is equal to 5, and I still don't yet know a. And this is where that formula comes in handy. So I'm going to plug it into the formula a squared is equal to b squared plus c squared, which gives me a squared is equal to 5 squared plus 6 squared, which tells me that a squared is equal to 61. That also means that a itself is equal to the square root of 61, but since I'm trying to find the equation, I only need the values squared anyways, and then that's my final step, is to plug everything in to get my equation of the ellipse, which is x minus 2 squared over 61, my a squared term, y minus 5 squared over 25, which is my b squared term, is equal to 1. And that's our answer.